Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on mesh analysis using the Supermesh concept. For the following network, find power supplied by 2.2 volt source. First of all, mark the meshes as mesh 1, 2, 3 and 4. Mark the mesh currents as I1, I2, I3 and I4. By mere inspection we can write I1 is equal to minus 4.5 ampere. So no need to apply KVL for loop 1 as I1 is known, where I1 is the loop current. No sense to apply KVL for loops 3 and 4 as 2 ampere current source is common to loop 3 and loop 4. Now applying Ohm's law. Voltage drop across 2 ohms resistance. V2 is equal to 2I1. Voltage drop across 3 ohms resistance. V3A is equal to 3I2. Voltage drop across 4 ohms resistance. V4 is equal to 4 into I2 minus I4. Voltage drop across 9 ohms resistance. V9 is equal to 9 into I1 minus I3. Voltage drop across 6 ohms resistance. V6 is equal to 6I4. Voltage drop across 1 ohms resistance. V1 is equal to 1 into I4, 1I4, and voltage drop across 3 ohms resistance. V3 is equal to 3I3. Apply KVL for loop 2. Loop 2 consists of 2 independent voltage sources and 2 resistors. Voltage drop across 3 ohms resistance. V3A is equal to 3I2 and voltage drop across 4 ohms resistance. V4 is equal to 4 into I2 minus I4. Apply KVL for the second loop. We will get minus V3A minus 5 minus V4 minus 2.2 is equal to 0. So as mesh current is taken in the clockwise direction, and when we consider voltage drop across 3 ohms resistance V3A, as we move from positive potential to negative potential, that term should be taken as negative. When we consider 5 volt source moving in the clockwise direction, as we move from positive potential to negative potential, that 5 volt source should be taken as minus 5. As we move in the clockwise direction, when we consider V4, as we move from positive potential to negative potential, V4 should be taken as negative. When we consider 2.2 volt source, as we move from positive potential to negative potential in the clockwise direction, 2.2 should be taken as negative. Therefore, we can write minus 3VA minus 5 minus V4 minus 2.2 is equal to 0. V3A is equal to 3I2 and V4 is equal to 4 into I2 minus I4. So applying these equations in the loop equation for loop 2, minus 3VA minus 5 minus V4 minus 2.2 is equal to 0. Minus 3I2 minus 5 minus 4 into I2 minus I4 minus 2.2 is equal to 0. Opening the brackets and rearranging the terms, we will get minus 7I2 plus 0I3 plus 4I4 is equal to 7.2, equation number 1. By inspection, we can write I3 minus I4 is equal to 2. Therefore, we will get the final equation as 0I2 plus I3 minus I4 is equal to 2, equation number 2. Combining loop 3 and loop 4 to form a super mesh, which consists of 6 voltage terms. Voltage drop across 3 ohms resistance V3, voltage drop across 9 ohms resistance V9, voltage drop across 4 ohms resistance V4, voltage drop across 6 ohms resistance V6, voltage drop across 1 ohms resistance V1, and the independent voltage source of value 3 volt. So we have to consider the loop current as clockwise. When we consider voltage drop across the 9 ohms resistance V9, as we move from negative potential to positive potential, the V9 should be taken as plus V9. When we consider voltage drop across 4 ohms resistance V4, as we move from negative potential to positive potential, V4 also should be taken as positive. When we consider V6, as we move from positive potential to negative potential, V6 should be taken as negative. When we consider V1 voltage drop across 1 ohms resistance, as we move from positive potential to negative potential, this term should be taken as negative, minus V1. When we consider 3 volt independent source, as we move from negative potential to positive potential, this term should be taken as positive, plus 3. And when we consider 3 ohms resistance voltage drop, as we move from positive potential to negative potential, this term should be taken as negative, minus V3 is equal to 0. According to Ohm's law, V4 is equal to 4I2 minus 4I4, V6 is equal to 6I4, V1 is equal to 1I4, V9 is equal to 9I1 minus 9I3, and finally V3 is equal to 3I3. So applying these equations in the equation for the super mesh, we will get 9I1 minus 9I3 plus 4I2 minus 4I4 minus 6I4 minus I4 plus 3 minus 3I3 is equal to 0. 9I1 plus 4I2 minus 12I3 minus 11I4 plus 3 is equal to 0. It is given that I1 is equal to minus 4.5 ampere. Therefore, we can write 9 into minus 4.5 plus 4I2 minus 12I3 minus 11I4 plus 3 is equal to 0. Minus 40.5 plus 4I2 minus 12I3 minus 11I4 plus 3 is equal to 0. 4I2 minus 12I3 minus 11I4 minus 37.5 is equal to 0. 4I2 minus 12I3 minus 11I4 is equal to 37.5, equation number 3. Now we have 3 equations. Minus 7I2 plus 0I3 plus 4I4 is equal to 7.2. Equation number 1. 0I2 plus I3 minus I4 is equal to 2. Equation number 2. 4I2 minus 12I3 minus 11I4 is equal to 37.5. Equation number 3. Solving the above equations, we will get I1 is equal to minus 4.5 ampere, it is already given. I2 is equal to minus 2.84 ampere. I3 is equal to minus 1.17 ampere. And I4 is equal to minus 3.17 ampere. So we are asked to find power supplied by 2.2 volt source. So current sourced by 2.2 volt source I is equal to I1 minus I2. The direction of current I matches with the direction of current I1 and it is opposite to the direction of current I2. That is why I is equal to I1 minus I2. I1 is equal to minus 4.5 and I2 is equal to minus 2.84. Therefore, we will get I is equal to minus 4.5 minus 2.84. I is equal to minus 1.66 ampere. Therefore, power supplied by 2.2 volt source is equal to 2.2 into minus 1.66. That is, power supplied by 2.2 volt source is equal to minus 3.652 watts. So power supplied by 2.2 volt source is minus 3.652 watts. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.